This lesson is on the sine and cosine ratios. If you see the specific example you're looking at below, you can download the app referenced in the video caption and use it to quickly navigate all of my Math 10 lessons and examples. So you can use it to go directly to the example that you're working on. The sine and cosine ratio function, what are they? So trigonometry is the study of math that deals with triangles. Tri signifies three sides of the triangle. There are three main functions that are used in trigonometry: the tangent function, the sine function, and the cosine function. Functions are equations that help you solve something you don't currently know. Defining the sides of a right triangle is covered thoroughly in the tangent ratio lesson. So if you have not done this lesson, please do this one first. I cover labeling the sides of the triangle correctly in the first part of this lesson. It is necessary to know how to label the sides of a triangle to do all of the examples in this lesson. We will now look at how to use the sine and cosine ratios for finding lengths or angles that are unknown in a right triangle. Important reminder, these ratios can only be used for a right triangle. That is a triangle with one angle being exactly 90 degrees. The sine and cosine ratios are defined as sine of theta equals opposite side length divided by hypotenuse side length. Cosine theta equals adjacent side length divided by hypotenuse side length. Find the sine and cosine buttons on your calculator. So what do the sine and cosine ratios mean? When you press the sine button on your calculator and then put in a value for the angle and press enter, your calculator will give you a number, usually a decimal number. Given the sine equation above, the decimal number is equal to the opposite side length of the right triangle divided by the hypotenuse side length of the right triangle. This means if you know one angle in your triangle and you know the hypotenuse side length in your triangle, you can find out what the opposite side length of the triangle is. That is, solve for the opposite side length. The above is true for the cosine ratio as well, except instead of dealing with the opposite and hypotenuse side lengths, you are dealing with the adjacent and hypotenuse side lengths instead. What's powerful about the sine and cosine ratios is that they can be used for any size of triangle, since it doesn't matter to the sine or cosine ratios what the side lengths actually are. It only cares about what their ratio is and what the angle is. It calculates the value for the ratio of the sides and relates this to the angle in question. This is why it is typically a decimal number, since it comes from a fraction ratio. Let's look at some examples. Example 1. Find side length x in the below triangle. So relative to the 27-degree angle, this side is the opposite side. This side here of 14 centimeters is the hypotenuse side length. And this third side is the adjacent side length relative to the 27 degrees. Again, if this looks confusing to you guys, please go over the tangent ratio lesson. I cover how to label the sides of a triangle in detail in the first part of that lesson. So because we're dealing with the opposite and the hypotenuse side lengths, we're dealing with a sine ratio here. Let's plug in what we know. 27 is the angle, x is the opposite side length, 14 is the hypotenuse side length. Now we need to solve for x, so we do this by using algebra. The only way we can get rid of that 14 on the right-hand side, because we want x by itself, is multiplying 14 on the right-hand side. So those two 14s will cancel. But we can't just go and do that. We need to do the same to the left-hand side to keep the equation balanced. We don't actually want to change what the equation means. So if you do the same thing to both sides, which is the basis of using algebra here, you're not actually changing it. And so you're left with x side length equals 14 times sine 27 degrees. Plug that into your calculator, and you get x equal to 6.4 centimeters. And you can put this quickly in your calculator by just plugging in 14 sine 27. It will know to multiply 14 by sine 27 degrees. Remember, sine 27 degrees is just a number. If you just put that in your calculator, you'll get some decimal number. Example 2. Find side length h in the below triangle. So h is the hypotenuse side. 17 centimeters is the opposite side relative to the 20-degree angle. And our third side is the adjacent side relative to the 20-degree angle. So because we're dealing again with the opposite and hypotenuse side lengths, we're dealing with the sine ratio. Let's plug in what we know. 20 is the angle, 17 is the opposite side length, and h is the hypotenuse side length. We need to get h by itself, i.e. we need to solve for h, so we need it in the numerator and only by itself on one side of the equation. So right now it's in the denominator, we need to deal with that first. We'll multiply both sides by h to get it up to the numerator. So it cancels on the right hand side, and we're left with h times sine 20 degrees equals 17. So one last step to get h by itself. Remember, sine 20 degrees is just a number, so we treat it like any other number or variable in algebra. We can divide both sides by sine 20 degrees. And we're left with h equal to 17 divided by sine 20 degrees. Plug that into your calculator, so 17 divided by, and then sine 20 degrees, end your bracket. And you should get 49.7 centimeters. Make sure you can get that in your calculator. Example 3, find side length B in the below triangle. So we have B is this hypotenuse side. Relative to the 38-degree angle, this side length of 11 centimeters is the adjacent side. And our third side, relative to the 38-degree angle, is the opposite side. So because we're dealing with the adjacent side and the hypotenuse side relative to 38 degrees, we're going to use the cosine ratio. Let's plug in what we know. 38 degrees is our angle, 11 is our adjacent side length, and b is our unknown side length, our hypotenuse side length. So let's find out what b is. Let's multiply both sides by b to get it into the numerator. We have b cos 38 equals 11, and now again, cosine 38 is just a number, so to get rid of it on the left-hand side next to that b, divide it by cos 38. That'll cancel the cos 38 on the top. We have to do the same thing on the right-hand side to keep things balanced. And we're left with b equal to 11 divided by cos 38 degrees. And now just plug that into your calculator, and you have b equal to 14.0 centimeters. Example 4, find angle M in the below triangle. So 17 centimeters is the hypotenuse side length. Again, it's just the longest side length of your right triangle. Relative to angle M, this side length of 8 centimeters is the adjacent side, and our third side is the opposite side relative to angle M. Because we're dealing with the adjacent and hypotenuse sides relative to angle M, we need to use the cosine ratio. So let's plug in what we know. 8 is the adjacent side, 17 is the hypotenuse side. And now we need to solve for m. So this is a little more tricky. We need to use what's called the inverse cosine, or the arc cosine, or cosine to the -1 is what it could be labeled as on your calculator. I've always seen it as the second function of the cosine button. So you need to hit your second button typically, and then the cosine, and then that'll activate the cos to the -1 button. So you can think of this cos to the -1 as kind of canceling out the cosine on the left-hand side to get m by itself, because that's always what you want to do in algebra to solve for your unknown. You need just that by itself. We don't want cos m by itself, which is what we had in the row up. We need m by itself to find out what m is. We don't want what cos m is. Although sometimes they'll ask you that on a test, which is even easier. Then you just need to put in your calculator 8 divided by 17, and you'll get some decimal, and that's your answer. That's what cos m is. But really, you usually want, in reality, the angle itself. So you can think of, that cos to the -1 is canceling out the cos on the left-hand side. We have to do the same thing on the right-hand side, and it is critical here to bracket the 8 divided by 17. You're taking cos to the -1 of the entirety of 8 divided by 17. So now you can plug this in your calculator, push second your cosine button, which is what it should be on your calculator. It might be something else, but that's probably what it is. The bracket should start automatically. Plug in 8 divided by 17, and now make sure to close your bracket. If you don't close your bracket, your calculator will probably find out cos to the -1 of 8, and then divide that number by 17, and that will be the wrong answer. And so you should get 61.9 degrees. And there's a little side note on, again, using the cos to the -1 function. Remember, this is used when you don't know the angle. Think of it as being the angle, that m there, it's stuck within the cos, and they're kind of connected, and you can't just divide by a cos here to get rid of that cos. You have to use this special cos to the -1 button. Same goes for the sine and the tan. You'd use sine to the -1 and tan to the -1. So there's an easy way to remember trig ratios and functions. It's called SOHCAHTOA. So saying it like that helps you to memorize it, and you can just write it at the top of your test when you're doing it. Just write down SOHCAHTOA right away. You can write it on the top of every page, so it's ready there. And then you're not really dependent on a formula sheet for your sine, cosine, and tangent functions. So SOH, the SAW, stands for sine, opposite, and hypotenuse. You'll notice it's taking the first letter of each of those words. And you can form your equation now from just knowing that SAW by writing the sine on the left-hand side, and then equaling the O for opposite is the top of the right-hand side of the equation, and H for hypotenuse is the bottom on the right-hand side of the equation. And that's always how it is formed now for the CA and the TOA. So CA is for the cosine. That stands for the cosine. A is for adjacent. H is for hypotenuse again. So you use the exact same way of writing it out. So see, the first word, cosine, is on the left-hand side. A for adjacent is the second word. That's on the top, on the right-hand side. And then H for hypotenuse is on the bottom side of the right-hand side of the equation. So you can see C, A, and H there being formed from the CA. And now TOA, exact same. You have tangent, opposite, and adjacent. You can see the first word T, the second word O for opposite, and the third word A for adjacent. So take this slide in, and you'll never need to depend on a formula sheet again the rest of your life, as long as you remember SOHCAHTOA and how the sine, cosine, and tangent formulas are formed from that memory mechanism. So let's look at some examples real quick, and I'm not actually going to solve it. You should be able to solve it from looking at previous examples, but this will show you how to quickly figure out which of the trig ratios, sine, cosine, or tangent, to use when looking at a question. So this example here is asking you to find what angle x is in the triangle. So write down the variables that you know. With respect to the angle x, 1 is the opposite side length, 2 is the adjacent side length. So you're dealing with O and A, opposite and adjacent. So looking at SOHCAHTOA, you can see that O and A are next to the T. So that's the tangent formula that we'll need to use. Tan equals opposite over adjacent. And for review, solve for that x. If you don't remember how, please see example 4 from the tangent ratio lesson. And note that I've put the answer there to make sure that you can get the right answer. So find side length x in this triangle. Write down the variables that we know. Relative to the 30 degrees, 3 is the opposite side length, x is the hypotenuse side length. So we're dealing with the O and the H. And now what are O and H next to? They're next to the S there. What was S again? That's the sine. So you use that formula. And again, solve for x as review. If you don't remember how, see example 2 of this lesson. And I've given you the answer there. Find side length x in this triangle. Wait a second now. This is not a right triangle. X cannot be solved for by any of the SOHCAHTOA formulas, as they can only be applied for triangles that have a 90-degree interior angle. So it's pretty obvious there by that image, if it's drawn to scale, that it is not a right triangle. You cannot use any of the SOHCAHTOA formulas. And example 8, find side length x in this triangle. This is a right triangle. I'm explicitly showing that there's a little square at the bottom right hand side there. That means that's a 90-degree angle. Let's write down the variables that we know. With respect to the 20-degree angle, x is the adjacent side length, 4 is the hypotenuse side length. So looking at SOHCAHTOA, which of them have A and H? It is the C that is linked to the A and H. What's C again? That's the cosine. So we'll use the cosine to solve this question very quickly. Again, for review, solve for x. If you don't remember how, see example 1 of this lesson. It is a similar example, except it uses sine instead of cosine. And I've given you the answer there so that you can make sure you can do it. And that is the end of this lesson.